Hello there, are you okay? It's advanced mathematics again, and you will be with Mr. Kimati as we discuss the topic called coordinate geometry 1, as you understand from Form 5, and we'll be doing the revision on ratio theorem. So please be with me so as you can remind yourself on this as we start to the end of the session. Welcome. Okay, today we will cover the following. We'll cover, first of all, we shall define. If there are some few definitions to define, then we shall define. And then after that, we shall try to derive the derivation of the formula for internal division. And then after that, we shall do some few examples on internal division of the line. And then after that, we shall derive the formula for the external division of the line. And then after that, also we shall try to do some few examples if there is time. And then after that, I will leave you some few more questions for you to practice more. As you know, we have two types of division of a line. First of all, we have internal division of a line, and then after that we have external division of a line. But I will also discuss with you the trisection division of a line as we go on, and I will show you how it goes. To you, it will be a new term, but I will try to explain it as we go on. Ratio theorem. Ratio theorem is a theorem used to determine the internal and external division of a line joining 2 points. As we know that a line is formed when 2 points are joined together. Let's say you have a point A and a point B, and they are joined by a straight line, and it is known as a line. So we are trying to find a point that can divide the units of those two lines to be divided into two equal parts, either internally or externally. And then we shall see how can a line be divided externally and how can a line be divided internally. So there are 2 points that can be divided, let's say, internally and externally, and we shall try to observe that. And then after that we say there must be a ratio that will be that will guide the division of a line. That means there must be a certain kind of a ratio that will guide either the division to be either equally or at a certain ratio. So we shall see how that ratio works. And we say there must be a ratio that will guide the division of a line, and that ratio will determine where the point that divides the line will be. That means this point that will divide that line will depend very much on the ratio that will guide us when we are trying to divide that line, either internally or externally. So let's see how will it look like. Let's check. Internal division of a line. Internal division of a line. Consider the diagram below that I will show you shortly. That shows the internal division of a line in the ratio m/n. So the line segment that I will show you will be divided into two segments that will be in a ratio m/n. Now the diagram is like this. Consider xy plane, and this we have point A and we have point B. With the coordinates from A we have x1, y1, and from B we have x2, y2. Now let's have the point P that will divide those two coordinates or that line segment by a ratio m/n, and that point P could be x, y. Now if you try to observe that much careful, you will see that you can connect these two points A and B in a triangle and have a point C there. And also you can connect that and have a point D there. And then you will see that these two triangles, triangle ACP is similar to triangle PDC. So we shall use those two triangles and they use the laws of similarities or the theorem of similarities to show how can we find the values of x and y so as we can obtain the division or the point that divides the line internally in a ratio m/n. So let's check it out. Division. Now we have xy plane, the xy plane, and this is the point A and that is the point B as it is shown there, and this is x1, y1, and this point here is x2, y2. Now we have said we have the third point That is point P. Point P. And that point P is x, comma y. X, comma y. Now, what are we trying to say? We are trying to find the values of x and y, because we have the values of x1 and y1, and we have the values of x2 and y2. Now we are trying to find the value of x and y. So as this line segment could be divided in a ratio, So as this line could be divided in a ratio m, ratio n. So this is what we are trying to see. Our aim is to get the values of those points. Now let's see. From this point x1 to point x, we know that the value of x there could be x, where the value of x1 could be there. That is to say, we have that distance from x1 to x. So we can join this also from there y1 to y. That could be in that way. That is to say, we have a triangle there. That will be a triangle. And also we can join that part 2. We can join that part 2 and have those. So that is to say, we can let this here as a C and here as a D. So these are two triangles and they are right angled triangles. They are right angled triangles. And as you can see, these two triangles, we can remember there is point P, we can say triangle ACP is similar to triangle PDB. PDB. These two triangles are similar. As we know, we can show this by the use of similarities. You can use the theorems of similarities and show the similarities of those two triangles. Now, if the two triangles are similar, we can also show the ratios. That means the ratios of the distances are also equal. So we can have, let's say, AC divided by PD, PD, AC by PD is equal to what? CP over DB. And is equal to what? AP over PB. That's how we look like. AC, that means these two, divided by that, is equal to what? Is equal to CP divided by DB, and is equal to what? AP over PB. So that's how it looks like. Now let's use those coordinates and try to write that in a very good manner. How will it look like? Let's check it out. We have AC there. That is to say, we have the distance from A to C. We have x minus x1 over PD. There is P and there is D. That means we have x2 of minus x is equal to what? Is equal to CP. And what is CP? CP. That is to say, is y minus y1 over dB there. So it is y2 minus y equals to what? Equals to AP, and what is AP? Is M over that thing there. Now, our aim here is to get the values of x and the values of y. So if this expression here is equal to that expression, that is to say, this expression is also equal to the last one, and the second one is also equal to the last one. So we can use these two cases and have the values of x and y. So as we can have the values of x and y, that will divide that line internally. Now let's check. Let's start with the first one. Let's start with x minus x1 over x2 minus x equals to m over n. And our aim is to get the value of x there, which is common. Now let's check it. It will be n x minus x1, and there we have m x2 minus x. So let's open the brackets. Let's open the brackets. How will it look like? We have nx minus nx1 equals to mx2 mx. And what next after that? Let's correct like terms. What are we going to have? We have nx plus, this comes to this side, mx equals to what? Equals to, equals to mx2 plus nx1. And we can factor out an x. We can have n plus m equals to mx2 plus nx1. And what is our aim? Our aim is to obtain the value of x. That will be mx2 plus nx1 n plus m. So this is the value of x that will divide that line internally in that ratio m comma m ratio n. That is. So let's retain it there. Let's put it and leave it there. And now let's go to the second part. That means we're going to use these two. First time we used this and that one. Now we're going to use this and that one. That is to say, we're going to have y minus y1, y2 minus y equals to m over n. So the same procedures happen again. We have m y2 minus y n y minus y1. Now let's open the brackets. We have my2 my equals to ny ny1. And collecting like terms, we're going to have this comes to that side and that goes to that side. What will happen? m y2 plus n y1 n y plus m y. We can factor out a y and plus m, and in this side we have m y2 plus n y1. What will happen? Let's divide it and let's put things. Okay, so we have a y equals to what? m y2 plus n y1 over n plus m, m plus n. So this will be the coordinate of y when that line is divided internally the ratio by the ratio m n, ratio n. That will be our points. So combining those 2 points, that means x comma y equals to what? mx2 plus n x1. We have n plus m comma m y2 n y1 n plus. So that will be the formula that will be used to find the points or the coordinates when the line is divided internally by that ratio m ratio n. And the points were x1, that was point A, and point B was x2, y2, and divided internally by the point P, x comma y, in a ratio m ratio n, and this will be our formula now. So given 2 points and a ratio, and we are told to find the division of a line internally, so that formula will be used, as we can see in the next example. So please make sure you know how it is found and make sure you know how it is used. Now let's go and use it. So sometimes you can be given a ratio and a 1 point and the point that is divides those 2 points, and you can be told to find the other point. Or sometimes you can be given the 2 points and you are told to find the point that divides those. And sometimes also you can be given those 3 points, that means point A, P, and B, and you are told to find the ratio. It can happen, you can be given a question like that. Let's see a question that tells us to use this formula. Now, examples on internal division. So example number 1 says, find the coordinate of a point which divides the line segment joining the points A, B and point B, that is 4, 3 internally in a ratio 1:2. Now let's see how can we do that. That is to say, if we call this is x1 and then this will be y1, and if that is x2, that means that will be y2, and that is m, that will be n. So let's see how will it okay, I will use the diagram. So but it's not that much necessary for you to do the diagram. I'm just using the diagram so that as to illustrate of what will happen. So we have a point A that is 2, 3, and we have a point B that is 4, 3. That is to say, if this is x1, that means this is y1, and if this is x2, that is, and we have a ratio that is 1:2. That is to say, this is m and that is n. So it is fairly easy. It's fairly easy. How can we find that? Let's use the formula. We know that the formula says x, y equals to what? Equals to m x2 plus n x1 n plus m, comma m y2, sorry, plus n y1 over n plus m. Writing the formula correctly is one of the best steps that you can do so as to obtain the good or clear answer. So if you don't write the question that much clear, then your answer, I assure you, will be wrong. So let's see. We have the first m is 1 multiplied by x2, and what is x2 is 4. Remember the, so let me give you one advice. Label these points so that you cannot be confused. Label these points as I did. I've labeled this is x2, y2, and this is x1, y1. So as when I'm trying to use it there, I won't be confused which one is x1 and which one is x2. Some of the students do find it's challenging to do this because they don't label. They think they can do it. Please, just do it. Just label it. Now let's go. Times 2. This is x1. And what is x1? x1 is 2 over, ratio is 1 plus 2, comma, we have y2, m, that is 1, multiplied by what? Multiplied by y2, that is 3, plus what? Plus n, that is 2 again, and multiplied by what? By y1. y1 is 3 over 1 plus 2. So please remember to label. If you don't label, I assure you will get the wrong answers. Now let's assure ourselves and make the mathematics clear. So let's cross check. So here we have a 4 that was x2, we have a 2 that was x1, we have 1 from m, we have 2 from there, and then we have a 3 from there, we have a 3 from down here, and we have a 1 from m and 2 from as the formula, and then there. Okay, so as we can be sure our answers are correct. So let's simplify that. We have 8 over 3, and that will be, so this is the point x comma y. This is the point x comma y. That is to say, the point x comma y divides the line AB internally in a ratio 1:2. So this is how it is found. This is how it is found. Very easy, very easy. I hope you do understand. Now let's check the second example and see what it tells us. So we are given a point P, that is 2,3, and a point Q, that is x2, y2, are endpoints. So these 2 points are endpoints of the line segment PQ, which can be divided internally by a point R. That means this is a point R in a ratio of 1:3. We are told to find point Q. We are told to find point Q. That is to say, if we try to connect from the example that was above, let's say P is like the A that we were given there. Q is like a B. And R is a P that we were looking there. So we can do this fairly simple, fairly easy. Now if we try to sketch it, we have something like this. Let's say a line like that, and there is a point P that is 2,3, and we have a point Q that is a line segment point Q. We have x2, y2, and we have a point R somewhere there, and this R is 5/2, 5/2. So we are told to find the point, the second point, while the ratio that divides this line segment is from there to there, we are told is 1, that is M, we can call it M, and from that point to that point is 2, that is N. That is N. So how are we going to do that? How are we going to do that? So the ratio is 1:3, sorry. It's 1:3. 1:3. So we have to find the point Q. We have to find the point Q. But we know the formula tells us like this. X comma y is equal to mx2 plus nx1 n plus m, comma my2 plus ny1 n plus m. This is the formula. And we've been given the point R. We've been given the point R. That is 5/2, 5/2. And if these are the x2 and the y2, that means this is x1 and the y1. So we have our m, and what is our m? Is 1, and x2 is there, plus n, that is a 3. Try to assure yourself while you are trying to do this part of the question, because if you try to mix these, then I assure you will get the wrong answer. Times x1, that is 2, over this plus that one. So we have 1 plus 3, 1 plus 3, comma, we have m, and m is what? Is 3. y2 is y2 as it is the point we are told to find, and then plus n, plus n. What is our n? Is 3. Oh, sorry, you see, there is 1, because it is m and there is n, so it is 3 y1, and what is y1? Is 3 over 1 plus. So we are to find the point, the coordinate that where it lies x2 and y2. That means this point. Now we shall compare this one and that one as x coordinate. We shall compare with x coordinate, and a y coordinate we shall compare it with y coordinate, and try to manipulate and have the values of x2 and y2. Let's see. Let's look on that. So it will be 5 over 3. 5 over 2, sorry. Then it is equated to what? If you try to multiply there, it is x2 plus, there is 6. And there we have a 4. Now let's manipulate that. It's very simple. And on the other side, we have a 5 over 2, which equals to what? Equals to y2 plus a 9 over a 4. So again, we have to find the value of x2 and y2. Now let's multiply by 4 throughout, and multiplying by 4 there, we know it will be 10 equals to x2 plus 6. And on that side, multiplying by 4 again, it will be a 10 equals to y2 plus 9. And let's find the value of x2. It will be a 10 minus 6. And on the other side, it will be a y2 equals to a 10 minus a 9. That is to say, x2 equals to a 4. And y2, oh sorry, there is y2. And y2 equals to a 1. Collecting those, that is to say x2, comma y2 equals to a 4. So this is the point R, is the point Q that we were supposed to find. This is the point Q that we were supposed to find. The point Q that we were supposed to find. Therefore, Q is a 4, 1. And a point Q is the second point from P to Q, and the division of that line is a point 5 over 2, 5 over 2. That's how we look on there. So you can be given anything. You can be given the point, find the ratio. You can be given the ratio, find the point, and so on and so on and so on. Now, external division of a line. Now consider the diagram below that shows the external division of a line, as I will show you down here. So we have a line that will be divided in a ratio m, ratio n again. And the diagram is, consider xy plane, and we have point A and the point B. Point A and the point B. And we have the point that divides these 2 points externally, that will be point P. And if you try to look that much careful, you will see that we have the distance from A to P, and also we have the distance now from B to P. And we shall try to find the point P, that is x, y, as an external division of these 2 points. As you can see, we can put this into a triangle. That will be triangle A, C, P. That will be the larger triangle, and a triangle B, D, P. You can construct that and see how it appears. And then after that, we can find the 2 points by the use of the theorem of similarities. As you can see, the triangle ACP is similar to triangle BDP, and also is similar to triangle AEB. But in our case, we shall use 2 triangles, ACP and a triangle BDP. And then after that, we shall use the theorem of similarity and the ratio of their distances to show how this point P is related to these 2 points A and B. And then after that, we shall find the value of x and y, and that divides externally the line segment AB in a ratio m, ratio n. Let's check it out. So we have a line segment, and that is A. Then we have a point B, and this is x1, y1, and this is x2, y2, and this is our x axis, and that is our y axis. Now we have another point that divides these lines, this line segment externally, that is point P, that is x, y. And try to join this. We have the distance from that point, from x1 to x, and from y1 to y. And again, we have the distance from x, we can call this point x2 to x, that is a distance that way. And we have a distance again from y2 to y. That is also a distance again. So we can call this, if this is A, B, and that is P, what if we call there is a C and there is a D? And again, to make that clear, so as we can have those two triangles or three triangles to compare, we can call also that a E. So you have those. But also you have the ratio. And this ratio divides the line externally. That means we are going from that point to that point. That will be our M. And again, we are coming from that point to this point. That will be our N. And that is so-called external division of a line. Now let's check it out. Let's check it out. How can we obtain the value of point X and Y from these 2 points and the ratio we are going to have? And that is to say, let's consider the two triangles A, C, P. That is similar. Triangle ACP, that is similar to triangle BDP. And as you know, if these two triangles are similar, then the ratio of their sides is also the same. That is to say, AC over BD, AC. What is AC? From there to there. And what is BD? From there to there. Is equal to what? CP, where is the C? CP over DP, over DP. And what is DP? That distance there. And we have AP, BP. This is a similarity from two topic, that is congruence and similarity. So you can go and revise that point and see how this look like. Now let's have those. Now after that, let's check the distances. That is to say, if we try to look that much careful, we have to find the distance AC. And what is AC? This is the point X. This is the point X. AC. That means from that point to that point. And XC minus X1 over BD, that is to say XC minus X2 equals to what? CP. And what is CP? CP. And what is our C? That means it's Y minus Y1. Y minus Y1 over DP. And what is DP? That means it's Y minus Y2 equals to AP from that point to that point, that is M over BP, that is N. Again, let's find the values of X and Y from this. That means if this expression is equal to that, that is to say, this expression is also equal to the last one, and the second is also equal to the last one. Now let's check it. Using that one, it is X minus X1, X minus X2 equals to M over N. And let's find the value of X. Let's open the brackets. We have X minus 1 equals to M X minus X2, and X and X1 equals to M X2. Collecting like terms, this comes to that side, we are going to have Nx minus Mx equals to this going to that side, we are going to have N X1 minus M X2. That is to say, if we try to factor out an x, we have n minus m equals to n x1 m x2. So we have x which equals to what? N x1 m x2 over n minus that thing. So you will notice the difference from the internal division. There we had a plus and now we have a subtraction sign. Now let's check the second one. We have y minus y2, y minus y1, or y1, y2, sorry, 1, 2, equals to what? M over n. Let's compare those. And let's multiply, cross multiply that. So we have our n multiplying by y minus y1 equals to m y minus y2. Opening the brackets, we have n y, we have n y1 equals to my m y2. Collecting like terms, we have ny minus my equals to n y1 minus m y2. Y equals to what? That will be like that. It's fairly easy. It's a making subject question, a form 2 question. So we have a y equals to those are the of x, and that is the value of y. That is to say, collecting those, we have n x1 m x2 n minus m, we have n y1 m y2 n minus. So this is how we can find the values of x and y if the line is divided externally. Now let's take the examples. Example number 1, find the coordinate of the point which divides the line segment joining points A and B externally by that ratio. It's very easy. Let's do it. To locate those points in our sketch, as I said earlier, it's not necessarily that you have this sketch, but it's a good practice for you to know how it looks. So we have a point that is 3, 2, and we have a 5, 7. And we have a point xy in a ratio of what? In a ratio 1, ratio 2. So that is our m, and that is our n. So how are we going to do it? So the formula, we know the formula is x, y equals to n x1 minus m x2 n minus m, n y1 minus m y2 n minus m. So this is the formula to find the points when the line segment is divided externally. Now let's check it out. We have this point, if we call that x1 y1, and this point is x2 y2, that means we are looking for the point P. Now let's go and check it. We have our n, that is 2, and what is our x1 is 3, minus m is 1, and x2 is 5. Remember to label those. It's very easy once you label it. And we have n minus m, and we have a 2 minus 1, comma. We have n, our n is 2, y1, and what is y1? Is 2, again, plus or minus m, what is m? M is 1, and we have y2, which is 7, over 2 minus 1. So if you label, it's very, very easy. Now we are going to have a 6 minus a 5 over 1, comma, a 4 minus a 7 over 1. That is x, y. So again, your answer will be x, y equals to what? To a 1. We know that 6 minus 5 is 1, comma, we have 4 minus 7, which is negative 3. So this is the point that divides a line externally. That means if we can call this P, and that will be our point that divides that line segment externally. Let's see the next example, or let me check the next example, or I can leave it as assignment. Now, the next question says, find the coordinate of the point 2, 4 and 1, -3 divided internally or externally in a ratio 2. So it is very easy. You can do that. You can do that. As I said earlier, you can be given these questions in 3 different types. You can be given all the 3 points and you are told to find the ratio. You can be given the ratio and 1 point, you can be told to find the other point. Or you can be given the 2 points and a ratio and you are told to find the point where this line segment is divided. So please be careful and try to check all those 3 types of the question and try to perform. The very easiest way to do that is to have one question like as we have there and try to hide that and try to find those, having those 2 points and a ratio, try to find that answer. Or try to hide those ratios and try to manipulate the answer and the 3 points to have the ratio. Or just hide 1 point and have the point and the ratio and the division, the point of where it divides, and find the other points. So it is very easy. You can have those answers. Now I want to explain one thing, the trisection. Now questions for more practice, you will find that I've tried to include one question that asks you, find the 2 points of trisection of the line segment joining point A and the point B. Find a point, 2 points of trisection. As we were doing in our case today, we were dealing with the internal and external division once we were just looking for 1 point. Now we have the case that is trisection. You are told to find 2 points. How are you going to perform this? Let's check it out. Now, given the question like that, that is to say, case number 1, first case, you will find the point that divides a line in a ratio 1:2. That will be the first case. And the second case, you will find the ratio that divides the line in a 2:1. That is to say, in a trisection, if we have a point there is P and there is a Q, that is to say, trisection tries to divide this line into 3 equal parts. That is to say, if the part is like there and like that, if these 3 parts are equal, it's just a sketch. That is to say, that distance there and that distance should be equal. Then, what are you going to do? You are going to find the point, let's say this is point R, and that is point, let's say, S. In order for you to have the point R, you are going to use this ratio. That means this from R to Q will be longer than from P to R. That will be this ratio, and it will be done. You will have 1 point. And the second point you will find once you have this point. That means from P to S will be longer than from S to Q. You will be using these 2 points. That is to say, you are going to have a 0,4 if this is point A and that is point B. Sorry for labeling it again, but it's for the matter of explaining, 6,4. That is to say, you will use this ratio by the use of the formula of internal division to find those 2 points, point R. The first case, I said you will use this ratio, and the second case, you will use that ratio. That will be the trisection of the points. And the second example says, the second question says, find the point of intersection of a line joining that. You can have those points and find the ratios. That means the midpoint of those, and then find the coordinate by those. Then it is very, very, very easy for you to do that. So please, my dear student, that's where I leave you today. You have a lot of questions to do out there. a lot of questions to do out there. Please over please, find those questions, perform them, do them, and have more practice. And I assure you, you will perform well and very much correct in your end exams or final exams. Be safe, stay at home, and you were with Mr. Kimati, a mathematics teacher. Bye.